Hello, Algebra 2! I hope you guys are having a great day. Today we are finishing up chapter 5, which is about our last day on radical functions. And we're actually going to be solving equations that have radicals in them. And so, that's our SWABAT, solving equations, dealing with radicals and roots. Ooh. Okay, so general steps. Number 1, isolate the radical first. Okay, you know how we're used to isolating the variable? Well, the variable is usually inside the radical, so you have to isolate the radical first. I was kind of thinking about this earlier, and I was thinking like isolating a radical is kind of like unwrapping a gift, right? If you have a gift and it's unwrapped, you're not going to start by like breaking it open and getting into the gift, right? You're going to start by unwrapping the bow and then getting rid of the bow, and then you're going to like take off the tape wherever that is. And then eventually, you're going to open the lid, and then you have like this box that's open, and then there's like frilly stuff on the inside before you get to your gift. And you have to take that out first before you actually get to your gift. And maybe you have to get the card before the gift, just to be polite, because you're only actually caring about the gift. And so like solving a radical is kind of like that. So like if you have like the x plus 2 plus 5 and 2 out here, and that equals 7, right? Your gift, the thing that you're really excited about, is the x, and like that's what you got to figure out, but you got to like unravel everything else first. So you got to like take away the 5 first onto the other side, and then you have to divide by 2, and you just have to like start pulling away layers to get to the x. You can't just like say, oh, I'm going to get rid of everything else before and then just happen to get x. You have to unravel things. Yeah. And unravel them and unwrap them in the right order. That's very important. Okay, so first you isolate the radical. Okay, then you just want to like raise both sides of the equation to whatever the power is on the, like, whatever the index is on the radical. You want to raise everything to that power, because remember, you want to undo the power. You want to take the power, or you want to take the root away. And so raising it to a certain power, a specific power, very important, specific power each time for each problem. Like if it's a cube root, you raise it to the third power. If it's a second root, square root, you square everything. If it's the fourth root, you raise everything to the fourth power. And then just simplify and solve. And also just be careful, just like with rational functions, where you couldn't have a 0 in the denominator, you still have to look for extraneous solutions for radical equations. And this will likely, well, not likely, but it might pop up if you have like the square root, even roots, right? Because you can't have negatives under even roots. So you got to make sure that you don't have anything negative under an even root. Example 1, solve the square root of x minus 9 equals 5. Well, the root is already isolated, so we just have to square both sides. And the square and the square root cancel, and so I get x minus 9 equals 5 squared, so that's 25. And then x equals 25 plus 9, which is 34. Box it. Example 2 is cube root of x minus 4 equals 2. Okay, this one, instead of squaring everything, you already have the radical isolated, so you don't have to do anything in that manner. But since it's a cube root, you want to cube everything instead of square everything. And so the cube and the cube root cancel out, and you get x minus 4 equals 2 cubed, which is 8. X equals 12. Box it. Example 3. Solve 2 times square root of x plus 1 equals square root of x plus 2. Okay, now this one is a little different. You could subtract 1 to the other side, but then you'd have to FOIL things, and that would be really nasty. This one is probably simplest solved, most simply solved by just squaring both sides. You just have to be careful because you have to square everything. So that 2 has to be squared as well. So it's like 2 squared times the square root of x plus 1 squared, which cancels out, and you get x plus 1 equals x plus 2, square root of x plus 2 squared, they cancel out. So you end up with 4x plus 4, right, because 2 squared is 4, distributed in, equals x plus 2, and then just solve. So bring the x over, we've got 3x equals 2 minus 4 is negative 2, x equals negative 2/3. Oh my gosh, I haven't been checking for extraneous solutions. We have to go back. Oh no. Okay, 34. Nope, you don't have a negative under a square root. Cube root, nope, that's not a problem because cube roots can have negatives under them. Okay, let's look for example 3. Negative 2/3 plus 1, that's a positive number, and negative 2/3 plus 2, that's also a positive number, so we're okay. Whew, good thing I didn't do any bad math. Oh my goodness. Okay. Example 4, we have x plus 18 equals x minus 2. This one, again, the radical is already isolated. Except, in this one we have to do a little more work, right? Because if I square both sides, I have x plus 18 equals x minus 2 squared. Not x squared minus 4. Do not do that. Don't do that. Please don't do that. FOIL. You have to FOIL, right? Because that's x minus 2 times x minus 2. So you get x plus 18 equals x squared first, outer minus 2x, so minus 4x plus 4. And then we can continue to solve for x. Bring everything over to one side because it's a quadratic, so we're going to have to factor, use the quadratic formula. If I subtract x, I have 0 equals x squared, and I have negative 4x minus 1x, so that's minus 5x. And 4 minus 18 is negative 14. And then we need to see if we can factor this out. Conveniently, x minus 7 and x plus 2 factors into this, equals 0. So x equals 7 or negative 2. And you just want to double check, make sure, plug those both back in. Is 7 plus 18 negative? Nope. Is negative 2 plus 18 negative? Nope. Okay, both of those answers can work. I like that progression. It's like easy, 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 and really difficult. Well, so I guess it's not that difficult. It's 2 times x minus 50 to the 1/3. That 2 cannot enter into those parentheses, so don't do it. Because remember, parentheses, then exponents, then multiplication. And since you have an x minus 50 inside parentheses to an exponent, you can't bring the 2 in first. Okay? That's breaking math rules. Don't break math rules. Okay, so we have a 2 that we need to deal with. And, well, if I cube everything, I can do that first. I can either divide by 2 first and then cube everything, or I can cube everything, just make sure I cube the 2 as well. I want to isolate the radical, so I'm going to divide by 2 first. And so I have x minus 50 to the 1/3, which is the cube root, equals negative 5. And then I'm just going to cube everything. So x minus 50 to the 1/3 to the 3rd power is x minus 50. And negative 5 cubed is negative 5 times negative 5, which is positive 25, times another negative 5 is negative 125. Add 50 to both sides, and we get x equals, it's a long equals sign, x equals negative 75, I think. And again, since this is a cube root, we can have negatives under the cube root, so any answer will work. So, hooray! Wow, those are some really easy problems. Man, I should have given you harder ones. And this is why little people scare me. Funny. Have a lovely day.